afternoon, everyone. We are group 13. So the theme of our toy is actually a mini basketball free throw game. So the name of our toy is, we call it the ball. And my name is Wycan. My name is Vincent.
I'm Caitlin.
I'm Naveen.
We're gonna talk about our toy. So I'm gonna start off with the background story. The reason and the motivation of our toy actually is to Actually, it's in honor of our Purdue basketball excellent form in the 2015 season. So we want to come up with a toy. Not only can ignite children's interest in basketball, we want to teach them some of the basic concepts in engineering, like some of the motions that we have here, like the projectile motion and some of the mechanisms that we use. We hope through this toy we can educate children on more of the concept and ignite their interest not only in STEM, we want to ignite the interest in basketball as well. So, Bala B-ball, the targeted group are children of 8-year-old and above. Why I said that? Because not only children can play that, adults with strong interest in basketball can definitely and would love to play with our toy. So what's very unique with our toy is, firstly, we have variable difficulty level. This was achieved by having a variable speed controller over here that controls the speed of this ring here, so that children can have different difficulty level to play with. And another thing unique about our toy is we included both electrical and mechanical system, different mechanism as well as the electric motor controller over there. And the most unique thing I feel about our basketball toy here is we have this auto reloading mechanism, whereas if we launch the ball over here, for example, I put it here, it will just automatically slide down to this launcher again. So with this simple concept of incline angle, we were able to make sure the ball reaches the launcher again, so that we don't have to reload it manually. So this is the CAD model of our toy. As you can see, it's really similar to what we have over here. Our toy consists of three main mechanisms. One is the crank slider mechanism that provides the horizontal movement. The rack and pinion mechanism that we use to create this launcher, as well as the electric motor controller over here. So I'm going to start off talking about the base. As I talked about previously, we have this base here with an inclined angle here, inward and outward, so that wherever we launch the ball, it just fall back to the launcher.
So here you can see we wanted to incorporate a rack and pinion mechanism to initiate our projectile motion for the ball. So we designed an arm that could release the ball, our basketball, at about a 45-degree angle. So we have a rack and pinion here. We attached a gear to our arm, and we have a spring-loaded push button that can translate, and the rack and pinion mechanism translates the linear motion of the push button into the rotational motion of the arm so that it can launch the ball.
So just to give you an idea about the crank and slider. So what is this? This is the driver, and then this is the connector, which will help to move the basketball ring forward and backward along the sliding path. Some of the things that we had to think about was to where to place those pivot points and whether we wanted to make the links shorter or longer. So the basic idea was to keep the length of the driver a little small, so that would have less torque being generated by the motor in case there's something went wrong. So that would not cause breakage or the linkages.
This is the computer simulation we created.
Play that simulation.
As you can see, that's the button gets pushed down, the arm goes up, and that moves back. And this is a video of our actual prototype. costing causes,
Oh, great.
such as
The rack that we 3D printed was very fragile.
the first house that just broke up, but we had planned for that, and we already had bought the metal rack for that. We installed that. We snapped the shaft, so we replaced it with a metal one in order to work, and we also broke the gear. And so some improvements would be to replace the, well, obviously the two changes we made: change the shaft to metal, change the rack to metal also. And the third one would be to make sure that these are thick enough to withstand any of those. We also would want to change the ball into an actual lighter material that flies better, because this is a little too heavy to make it in there. And the third one is to put a cap on top of here just for children's safety.
So we can demonstrate.
So it really just depends on how hard you press this and then how much we want this to. So if you really want to like time it and then press it on the time. So I don't know if it's like easy to put it in the yeah, that's the whole point of the game, I guess.
Thank you.
Thank you.
Any questions? You raised this.
Once, try to one of times. I
We've
did it
gotten
once.
pretty close. So.
Yeah. Actually, we even considered using one of the bouncy balls as our ball because this ball itself is too heavy.
It's extremely heavy because it's solid.
Yeah, it's
3D printed
pure
solid.
solid. Yeah, the angle was right. I think it matches what we wanted, but just we underestimated the weight of the ball. We thought it can fly.
Yeah. The trajectory varies based on like the force of the G bus.
Do you guys consider at all using like a lever, like a linkage or anything instead of the rack?
Yeah, so we originally considered using sort of a pulley mechanism for it, and we actually initially wanted to have an actual player instead of an arm, but it ended up being a little too complex to 3D print.